Hello friends, welcome to my channel. Today we will discuss about function, closure and generics. Now let's get started. Using fn keyword, we can define any user-defined function, and add is our function name. It takes two arguments, x and y. One important aspect to remember is that we have to explicitly specify the type. In our case i32, and the return type is i32 as well. And using return keyword, we can return x plus y followed by semicolon. If you use return, you must need to specify the semicolon as well. So result is the variable name of whatever is written from add methods. And this i32 is auto inferred, and this x and y you don't need to specify. And in the outside you can see this result is equal to 11. And this return keyword is optional. In most of the cases, the last line of any function is the return thing. Whatever you written in the last line, the value will be calculated and it will be returned. And you must need to remember that you should not provide the semicolon. If you provide the semicolon, the return type will be void. Now let's discuss about struct and methods. So we have created our standard struct point with two attributes x and y. And derived debug is helpful for printing the message on the console. So we created a simple p1 instance and we debug the print p1 values. So here we can see x and y is getting printed. Now we can provide some implementation for the struct. And all the implementation we can specify different methods, and those methods are tightly coupled with the struct. So using this impl keyword, then inside the struct, there is no way you can specify the functionality or method or function you can't provide. But if you use like impl point, so any methods which you define inside this is known as struct methods, or that would be accessible using this p1 variable. So most commonly this new is used. New. This is just a convention. This is a method. So instead of new, you can use any other method name. But as per the convention in the Rust community, the constructor usually used by new keyword. Inside this new keyword, you usually instantiate a point type, and this self is nothing but the point. So instead of self, you could have written the point. It will work fine. So point xy value, x and y are the inputs, and this is like signature. If you see there is no return, there is no semicolon. That means this particular instance will be written from this new function. And now let's use this function. So like P1, there is a two-way. P1 we can create like point and like curly bracket. We can instantiate in this way, or we can leverage this new function or new method. This is known as new methods or associative methods, and we can pass these arguments, and this P2 instance will be created as well. So P1 is P2 is printed, and along with the new associative method, you can define any number of method inside the struct. Now let me define a simple method which doesn't take any arguments like origin, which does the same thing, but initially the x and y both is 0 value. So same way you can call here point origin. You don't need to pass any arguments. So P3 is getting printed. So the instance is created, and let's create some other associative methods. So in this case, like print is another type of method. And here the first argument is ampersand self. This ampersand self is the short form of the self colon point reference to the point. So whenever you can call this kind of function using any instance of point. So in this case, we can access this is a kind of this, because inside Rust there is no this keyword. The self is a pointer to itself. So using self.x and self.y, we can access the data with this point instance is referring to. So we can do p1 and point. So whichever the message you have put in the inside this function. In this case, we are printing x and y. So x equal to 1, y equal to 2. We are trying to print this p1. And this is a immutable difference. And inside this implementation block, you can define some function which can able to modify the content of the point as well. In that case, you need like you need a mutable pointer, mutable reference. And in this case, I'm passing this is a add function. I'm passing a tuple. Whatever the tuple I'm passing, I'm trying to add into x and y value. But one important point to remember, this is a mutable reference. Mute self. So self.x and self.y, we can mutate or we can update or modify it. So this is the tuple, or this can be any other point type or any other data type. This is like user defined. So important thing to remember that this is a mutable self-reference type. So I can do p1 add and I'm passing some values 10 and 14, 10 and 40. At this point it is complaining it because p1 is immutable variable and we are trying to pass this add inside this mutable reference. So this doesn't work. So to make it work, we have to change it to mutable. Now x and y is value is updated 11 and 42, and you can call like p1 dot print, or you can call in this fashion as well. So these two functions are identical. Either you can call all the methods associated with the struct using dot operator, or you can call this struct colon print and you can pass this reference. As I already said, this is like self mutable self is same as like self colon like mutable self reference. And this is like short part, either you can use the ampersand self or you can use the full bigger syntax. This is just for demonstrating what is it is doing under the hood. Or instead of self, if you want to write point, you can write point as well. So all three different styles are identical, but most commonly used are like this most commonly are used like ampersand self. Now let's discuss about closure. Closure are anonymous function. This is also similar to function with different characteristics. So we can, this function doesn't have name by itself. So which can take two argument x and y. If you want, we can specify the input type as well and the return type. And here if you want, you can use return keyword, or you can omit the return keyword and x plus y. So this is a function of add. So if you don't, there is no need for, in case of closure, there is no need to explicitly mention the type of that X and Y. So you can omit the type as well. And also you can omit this return type. So it will be automatically inferred. But if you save it, it will still complain. For example, it is complaining the type annotation is needed. So for getting that functionality, once you started using this particular closure, after that you define it, then it will automatically try to understand what is the type you are dealing with. In that case, this error will be gone. So because here I did the add and sub, if you explicitly mention the type, there is no error. But if you omit this type, if you not use it inside this program, then there would be some typo error. But as soon as you are calling this function add and sub, then this particular error will be gone. So here add and sub will work exactly like any normal function. Now let's define a particular string name. And here I am define a function hi. Here one important aspect to understand is that inside the closure, this closure doesn't take any input argument or it doesn't have any return type, but it tries to access this name. This is a very important and powerful concept inside closure. This is known as environment capturing. So any data, it can capture any variable which is defined outside of its scope. So this function not only have access to whatever the argument it passes as a pure function, but this closure do have the access to its environment, and it can access to the variable outside of its scope. And if you are only reading it, it is a immutable difference. So if you put hi profile is getting printed. And because it is a immutable difference, so this hi won't take this ownership of this particular name. So after that, if you also try to debug this, then also the name will be still available. So if you want to mutate this string variable, then you have to use let mute keyword. Because if you want to change this name inside this closure, and I define a closure name hello, one important thing is to remember that in the closure name also you have to use mute. So not only that variable, whatever you are changing, you have to put mute. Also the closure which is supposed to change this name, you have to put as mute. And inside this name dot post string, and you can append some additional data to it. And if you try to save, there is nothing is printed because we have not called yet. So whenever you are making call to hello, then this is printed. Hello profile suddenly will be printed. And if you see this particular debug line, also the data is changed from profile to profile suddenly. So whichever the data you modified inside this closure, that is getting affected immediately. And one important keyword is to remember when you work in conjunction with closure. If you want to pass this in this by default, hi name is only the immutable difference is being passed, so that it is borrowing this variable. But if you want to pass this ownership of the name, then you can use the move keyword. Then once this hi name is printed, this name will be destroyed, or the memory allocated for this name inside heap will be deallocated. See, because of move, it is complaining borrow of moved value. This name is already name has type string which doesn't have implemented copy trait. It is some additional information because name is not, for example, integer or some primitive data type you can copy. Even though you use move, so data would be copied. But if you are using some variable, for example, heap allocated, so it is not explicitly copied. So the ownership is getting transferred. So here we define a closure hi and another function Usually function are defined outside of main, but inside one function you can define the closure as well as function. There is no harm in doing that, it is allowed. So hi is printing some message and hi there is printing some additional message. So we can call another function which take input argument as another function. This f is nothing but a function. This is a very powerful concept. So you can pass any other user defined function to another function. And here you can do IMPL function. Whenever I discuss about trait, this fn is a trait. So I'll cover with IMPL in more elaborately. If you want to there are three different type of fn, a function trait, fn, fn1 and fn mute. To get a detailed explanation, see my closure video I created earlier. So here inside the call me, we can pass like closure hi, and we can pass like normal function hi there. So this hi and hi there is getting printed in this particular line. And we define another function like void. So by default, you can specify like return type as this simple two parentheses. This will be commonly used across the board. So there is this is not notified to returning nothing or void. And if you type last as this empty parenthesis, this is explicitly returning void. So if you want to debug this function call, so you will see this empty parenthesis here as well. So if you remove this last line and the return type, both the thing is not optional. So this will also behave the same. So if you do any kind of println with followed by semicolon, and if you are not, if you omit the semicolon, then this is try to return something. But if you put semicolon and you are not doing anything, that means you are returning void. So return the void here. So there is one other return type is exclamation mark. This is like it is not expected kind of thing. This function never returns. Because you are doing panic, this will be crash this program at this point whenever you call it. So this particular exclamation mark means this function return nothing. But this function never returns, not even void. So it is panicking. With this message in this case, this function never returns. Now we'll talk about generics. Generics in case of static typing is one of the very important concept and which is mostly used for the library author. And whenever you are trying to deal with any complicated library, so there must be probability that they leverage generics in a substantial manner. So I define a function ecobake, and this is like where this t will be declared. So instead of t, you can use a, b, c, d or multi-letter type, anything, whatever you like. In this case, type signifies for any type, integer, string or any custom struct, anything. So this particular function x can take any argument, and whichever that argument it takes as an input argument, same thing it is returning as well. That's why it is ecobake. So this is where this angle bracket is for declaration part, and this is and any other place wherever you are defining the type like integer, string, you can use the t in connection with that. So t is very commonly used, and this x is a variable name. So if you define like I32 here instead of t, you can only able to pass this integer type only. You can't able to pass any floating values. But because you pass like t here, we can able to pass like integer, float and string data. So if you want to print some information, this print curly bracket is not available for all the custom type. So here we can provide some bounds or some condition. This is just a simple t type specified, and you can use t as earlier, but here followed by colon, you are providing a trait name. This trait can be your own custom trait or it can be standard trait. So if you, whatever the functionality you are supposed to use under the particular function, the same trait bound you have to provide. And you are trying to say that whichever the argument you are trying to pass, it should follow this display trait. For example, all primitive integer, string, floating do have implemented already the display trait. They know what is the information you need to present. But if you are trying to pass like some your custom struct like point or employee, so if you don't implement this display trait by yourself, then this will complain. So in this case, like I'm passing this integer, float and string data, so all are getting printed because all these different types are already implementing this trait. You don't have to do anything. Rust by itself is providing the implementation, but you can't pass any struct to that your custom struct. And if you want to add here x and y you want to provide some add function where you want to add, like for example, integer, floats and character, but not string. So in this case you can mention like some trait name, and this add trait is available in the ops module operation, standard ops and add, and this is like already associative type. This output is, I'll cover it later, but this is a associative type which is pointing to the t again. If you see the add and add, so multiple functionality we can get, and both integer and floating point numbers are providing having this add trait they already implemented, and they know what needs to happen if you do plus between two integer and plus between two floating point numbers. And this 1 plus 2 is 3 and 30 is 10 plus 10.0 10 20.0 equal 30. And here this is if you have only only simple t without having any bound, or you have one bound, you can use this syntax. If you have multiple bounds, you can use plus operation, and here is where like it seems like SQL, but instead of writing in t, so if you have multiple trait, so this looks much more neat and clean. So you can specify after this input arguments where t colon to trait name and plus means end, that it must, whatever that functionality it will pass, it must have to implement display and debug as well. So once we pass a string literal, so debug print will be getting printed, because the string literal under the hood, like Rust provide the implementation for display as well as debug for trait. So in case of your user defined struct also, you can leverage this type. So instead of writing like xy both are integer i32, so you can have like t here, and you can use it, and it will ensure that x and y, there is no possibility of error that x may be integer, y may be float. If you specify generics, both will be having same data. And whenever you specify like this instance, depending upon the value 1 and 2, this t will be decided. You don't need to explicitly mention whenever you are instantiating that t is equal to i32. So P1 and P2. So P1 is pointing to that x and y value as integer, and whereas this second P2 is pointing to the floating data, and both are valid instance of it. Before I wrap today's video, I would like to give a big thank you to Rust by Example book. Most of the example or code snippet are derived from this book. Thank you for watching. Have a good day ahead. Bye bye.